Taking accurate and precise measurements are very important in chemistry. So in this video, we're going to introduce the idea of precision and accuracy. Here's some glassware that you'll be using. Significant figures. Significant figures are the certain or known digits of a measurement plus one uncertain or estimated digit. Now, you probably know this to be true just in your own experiences. If you were going to measure, I don't know, say the width of your bedroom, you might lay down a meter stick and you might measure that it's several meters wide. And then when you got to the end, you might discover that, well, the meter stick didn't fit exactly perfectly and there's some estimation required. So you maybe measured, 3 meters and then you had to estimate, well, 3.5, so you said 3.5 meters. So in that estimation of 3.5 meters, the certain digits were 3 because you knew that exactly. And then you estimated one more digit, the half of a meter extra that you had. So we're going to get lots of practice with significant figures. So in the number 135, the 2 digits in blue are certain and the 5 is an estimated digit. Same thing here. 45.9. The 4 and the 5 are certain digits and this 0.9 is an estimation. And same thing here. This 5 and this 0 are certain. And this last digit, this 0, that's an estimation. Accuracy describes how close a measurement is to the accepted or correct value. We're going to do quite a bit with this during the year as well. And it usually describes one measurement or maybe an average of some measurements. Now let's contrast that with precision. Accuracy and precision used in everyday life oftentimes mean the same thing, but in chemistry they do not. Precision is the consistency of your measurements. That is, how close together are your measurements. And it usually compares several measurements of the same object. Okay, describe the following data sets. Let's say we're shooting a bow and arrow, and we fire 3 arrows. Well, obviously you're intending to hit the bullseye. So the bullseye would be accurate. If you're not hitting the bullseye, that's inaccurate. So it looks like this is not by the bullseye, so these are inaccurate. But these are also close together, and anytime measurements are close together, that would be considered precise. So I would say that this data set is precise, but it's inaccurate. What about this data set? How would you describe those 3 numbers? Well, they're not close to the bullseye, and the numbers are kind of far apart from each other. So I would say imprecise and inaccurate. What about this third data set? Boy, that looks great. It looks like it's accurate and precise. Okay, I hope this made sense to you. If not, I've included a more real-life example here. The theoretical value for the density of gold is 19.3 grams per milliliter. Let's say you and your lab partner set out to determine experimentally what the density of gold was. And these were the 3 values that you got: 22.0, 22.2, and 22.1. How would you describe this? Well, this is what the value actually is, or this is the theoretical or accepted value, and these are the values that you got. Looks like your values are not that close to the theoretical value. However, all of your values are close together. So this data set would be precise and inaccurate.